It's pretty amazing when you think about it. Every single medical device, it all begins as just an idea, a simple thought, right? A question, maybe a spark of inspiration, all aimed at solving a real human problem.
But of course, that idea immediately hits a wall of really tough questions. Like, okay, how do you actually build this thing? How on earth do you make it safe? And maybe most importantly, how do you make it work not just in some pristine lab, but for a real person?
And right there, that's the magic. It's in answering those tough questions, in tackling those huge engineering challenges that we get to breakthroughs. The big ones, the ones that completely define modern medicine. So, welcome. Today, we are diving deep into the world of medical technology. We're going to trace that incredible journey all the way from a simple concept right through to a life-saving innovation. All right, so to really get a grip on where we're going, we've got to look back to the first revolutions, those aha moments when a simple new tool let us see, or, well, perceive, the human body in a way nobody had before.
Okay, just look at this timeline for a second. It's kind of mind-blowing, right? In less than 100 years, we went from barely being able to hear a heartbeat clearly to literally seeing inside the body with X-rays and then mapping the heart's electrical rhythm. This wasn't just progress, no way. This was a flat-out explosion of diagnostic power.
I mean, really think about what this meant. Before René Laennec came along in 1816, diagnosis was all about what a doctor could see or feel from the outside. That's it. So the stethoscope, it wasn't just another tool. It was the very first key that unlocked the body's internal world. It turned "I feel unwell" into objective, audible data. A game changer.
All right, let's jump forward in time. Way forward. From those early simple devices to today's high-tech toolkit, which is, just a little more powerful and complex. We're going to look at two absolute pillars of any modern hospital.
First up, the MRI scanner. Now, you've probably heard of it. An X-ray is fantastic for looking at bones, but an MRI, wow. It gives us this unbelievably clear picture of all the soft stuff, the brain, muscles, organs, tumors. And get this, it does it all using these super powerful magnets and radio waves, not harmful radiation. This was a total game changer, especially for diagnosing things like cancer or issues in the brain.
And this is where things get really interesting, because it highlights this crucial balance between power and precaution. That magnetic field in an MRI is so incredibly strong that the no-metal rule isn't a suggestion, it's absolute. A stray paperclip, a pen, it can become a dangerous projectile. It's a perfect, almost scary example of how great medical power comes with some serious engineering responsibility.
Okay, next up, the ventilator. And let's be clear, this isn't just another machine in the corner of the room. For patients in the ICU or under anesthesia, this thing is their lifeline. It literally takes over the most fundamental function of life, breathing, when a person's body just can't do it on its own. The engineering precision here has to be flawless. A ventilator isn't one size fits all. It has to be tuned perfectly for each individual patient. We're talking about managing the exact volume of air, the pressure inside the lungs, the oxygen mix, everything. And because it connects directly to the patient's airway, the rules for preventing infection are, as you can imagine, unbelievably strict.
And that brings us to a really crucial part of medtech, one that most people don't really think about. The huge challenge of engineering for safety. See, it's not enough for a device to work. It has to work safely, every single time.
So how do we make sure that happens? Well, regulators like the FDA have a smart system. They don't treat a bandage the same way they treat a heart valve. They use this risk-based ladder. You've got your Class 1 devices, super low risk, think thermometers. Then you have Class 2, moderate risk, like an infusion pump. But then you get to Class 3. We're talking pacemakers, artificial heart valves, stuff that is literally keeping someone alive. And those devices, they go through the most intense testing you can possibly imagine. And this slide shows you exactly why that level of scrutiny is so critical. The potential dangers are huge, and they come from all angles. It's not just the obvious stuff like an electrical shock or a mechanical part failing. Nope. In today's world, engineers are battling software bugs, the threat of hackers attacking connected devices, and even what we call human factors. Like, is the screen so confusing that a busy nurse could accidentally enter the wrong dose? All of it has to be considered.
Okay, so we've looked at the history, the tech, the safety challenges. Where does all this lead? What's next? Well, the future is all about making healthcare smarter, more precise, and way more personal.
And this right here, this captures the massive shift in thinking that's happening right now.
For the longest time, healthcare was reactive. You got sick, you went to the hospital. That was the model. But we're moving to something totally different, predictive and personalized. A model where technology helps keep you healthy before you get sick, with care that revolves around you, not a hospital bill.
And these are the amazing technologies that are making it happen. We're talking about AI that can spot a tumor on a scan that even a trained radiologist might miss. Surgical robots that enable ridiculously precise operations. Implants that are 3D printed to be a perfect fit for your body. And of course, the wearable monitors on our wrists, tracking our health 24/7. So this really is the big question for all of us, isn't it? Because this isn't science fiction anymore. This mashup of AI, robotics, and personalization, it's happening now. It's already reshaping how we think about our own health. So how is it going to change your life?
Of course, these incredible breakthroughs don't just magically appear. They are being designed, built, tested, and perfected by brilliant teams of engineers at companies all around the globe.
Now, this is just a quick look, but it really shows you how specialized this field is. You've got the huge players like Medtronic and Siemens, but then you have these super focused innovators like Edwards Life Sciences for heart tech, or Intuitive Surgical. They basically invented the field of robotic surgery, and Dexcom, whose wearable glucose monitors have been an absolute game changer.
When you boil it all down, it really comes to this one core idea. The next huge leaps forward in human health, they're not just going to come from a new pill in a bottle. They're going to come from new machines, smarter software, and better systems, all of it born from the minds of engineers.
And that brings us right back to where we started, doesn't it? Back to that simple but incredibly powerful cycle. An idea, a challenge, and the breakthrough that follows. That right there, that is the engine of progress in medicine.
And that's what this is all about. This is Echoes of Thought in MedTech, where we explore that exact intersection of ideas, engineering, safety, and the devices that are shaping the future of all of our health.
So if you're passionate about biomedical engineering, if you get excited about building smarter healthcare systems, then you're in the right place. Go ahead and subscribe.